So systems of linear equations, these are putting like two lines together and coming up with it. So there's three different ways to solve them, but what we are looking for is what point is on both lines. And the way you figure out what point is on both lines, you can graph it or do it two different ways algebraically. We'll go through all those today, but we are looking for the intersection point. That is a one point that is on three different lines, or I'm sorry, the two different lines. So there's only one point that falls on both of that, so where they intersect. There, when you talk about intersection, they you usually talk about perpendicular and parallel because it's the three types of intersections. So they either intersect at a 90-degree angle, which is perpendicular, the blue one, or they are parallel, which means they never intersect. Okay, so we'll talk a little bit about parallel. I don't think it really talks about perpendicular at all, but this is just the three types of intersections that you have. They either don't intersect, they either intersect at a 90-degree angle, which is perpendicular, or they intersect at some other angle, which is kind of more what we're focused on today. But when you get your answer right here, I want you to be thinking like, okay, this is like we're still looking for a point on the line, but we're looking for a point on line A and a point on line B, and the only point that would be on both of those lines would be the spot of intersection. Okay. So like I said, I don't think you'll do too much with perpendicular and parallel, but when we talk about two different lines, those are always just all the different ways that they can intersect. So as we go through these answers, we are going to be thinking like that is the intersection point. That's the point on both of these lines. The first couple topics are just starting out and deciding if it is an intersection point. So it starts pretty easy. I said there's technically three different ways to do it. You can graph it, and there's two different ways algebraically. Graphing it by hand, I'm kind of just talking right now, let y'all write this down because I know a lot of y'all are writing it down, that's fine. But graphing it by hand is kind of hard to do because we just don't, make everything proportionally accurate. So it's hard to see. We may actually find one of these that don't work out perfectly. I'll show you. But the main thing of this, like I said, you don't do too much with parallel and perpendicular, is that our solution is the intersection point. All right, so the first topic here is determining if it is a solution, okay? For it to be a solution, it has to work on both of the lines. It has to work on both of them. So we're determining if 2, 3 is a solution. So when I look at this, I can go back to that later if you need to. When you look at this right here, they give you a point, is 2, 3 a solution? So we're saying x is 2 and y is 3. And we're going to plug those into both of those lines to make sure it works. So on the first one, it's y equals x plus 1. So you put a 3 in for the y, a 2 in for the x. And this one's easy to say, okay, yes, that one works. And then you go plug it into that one on the bottom. Y is 3, negative 2 times x is 2, plus 7. So 3 equals negative 4 plus 7. Yes, that one works too. So this is the intersection point because it works on both of those lines. The only way that a point can be on both of those lines is if they intersect. All right, so to do it again, same idea here. We're plugging 2, 7 into both of those. So I plug a 7 in for my y, a 2 in for my x. So 7 equals 6 plus 1, 7 equals 7. That one works, so that point is on that first line, but it's got to be on both of them, so we go check the other one. 2 times x is 2, y is 7. So 4 plus 7, that does not equal 6. So this is a no. It is only on one of those lines. So what that means, I'll scroll back up here real quick, but what that means is that point's like over here. It could be on that line right there, but it's not on this line at all. So it is not the intersection. It's got to work for both of them. The next topic, I wouldn't even worry about drawing that graph out because it's hard to see on the graph. I mean, you can if you want to. But what you're looking at here is finding the solution from a graph. When you're looking at a computer, it's going to be a lot easier to identify, but this is, again, just teaching you that the intersection point is my answer. So this is the point that we're looking for. That's at x2, y3, and that is my answer. It's hard to tell that when you graph it by hand exactly if that's correct. You'll see that in just a second when we do it. But when you write that out on your paper, it's kind of hard to see too. So it'll give you, on this problem, it'll give you the graphs and then tell you to find the answer, the solution, which is the intersection point. All right. So graphing these, I'm going to go ahead and do these by hand because this is a good refresher for what we did last week too. But graphing these, like I said, it is hard to get your answer by hand, so it is a lot easier to use technology on these. So let's just see how this works. So we have the two equations, y equals 2x plus 1. So my slope is 2, which is 2 over 1. So what is that? Up 2 to the right 1. And my y-intercept is 1. So I start at 1. I go up 1, 2 to the right 1. And I get my answer there. Or I graph it, but then I go graph the red line. So my slope is, there's not a negative in front of there, so it's -1. So that's like -1 over 1. That would be down 1 to the right 1. And my y-intercept is 4. So I start at my y-intercept, 1, 2, 3, 4. And I go down 1 to the right 1. And I actually land right on that point, which could make this one easy. So we have our red line, which is y equals -x plus 4. Our blue line is y equals 2x plus 1. And our intersection point is this point right here. This one did work out to where I could see it pretty easily. Oh, wait, it's 1, 3, isn't it? 1, 3. But again, when you're graphing these, like your proportions got to be like just right to make it work out. And it's nice when it lands on a point, but it's kind of hard to see sometimes otherwise. Oops. All right, so I'm kind of, like I said, I'm kind of going over these as a refresher of last week because it's a lot easier to do on a computer. This next one, what is my slope of the blue line? Anybody? Nobody? Nobody wants to take a guess? Yeah. Yes, why are you saying -2, you know? Before you identify the slope is not just a number in front of x. The first thing you got to do is put it in y equals mx plus b. So I subtract 2x from both sides. Now it looks like y equals mx plus b. And now I can identify the slope. So I was trying to trick you there. It's not just the number in front of x. It's the number in front of x when it's in y equals mx plus b form. So my slope is -2, which is -2 over 1. So I go down 2 to the right 1, and my y-intercept is 4. So I start at 4. I go down 2 to the right 1. And that is that equation. That is my 2x plus y equal 4 equation. And then my red one, same thing. I need to put it in y equals mx plus b, so I subtract x from both sides. But I still have a negative in front of x, or I'm sorry, in front of y, negative in front of y, so I divide everything by -1, and I get -1x divided by -1 would be positive x. 1 divided by -1 would be -1. So my slope is a number in front of x. There isn't a number, so it's a 1. So 1 over 1, I'm going to go up 1 to the right 1. And then my y-intercept is at -1. So I start at -1. Whoops. And I go up 1 to the right 1. Okay, so this is, I didn't even draw this good. My intersection is somewhere right here. It does kind of look like it's in between those. So this is why it doesn't work very good by hand. on Alex, you're going to have a calculator, but I just wanted to show you like why it doesn't work out. Oh, no, it deleted mine. What was it? It was 2xy4. I had it in there for us, so I didn't have to type it in. And then it was x minus y equal 1. So the point of intersection, like if you need to use Desmos on these, you can, but you should be able to see it pretty clearly on Alex. So the point of intersection on this one is actually 1 2/3 and then 1 2/3 and 2/3. So this is why it's hard to do it by hand. 1 2/3 and 2/3. Because if it doesn't land perfectly like our last one did, it does make it hard to find. So this is why we don't do it by hand very often. It's a lot easier to do it algebraically, unless we have technology. Technology, obviously, if you saw me do it in Desmos, it takes 2 seconds to get the answer. All right, so we don't do the graphing the way that much, but I wanted to go over those just as a refresher from last week. This one right here, the algebraic way. So there's 2 different algebraic ways to do it. When I do algebra stuff in this class, I try to only do it one way, and like the one way that works for all of it. This is probably the few scenarios where I'm going to tell you that it is actually easier to do it one way one time, and then the other way, do it the other way all the other times. This is called the substitution way. When you have a variable like already all by itself, like this y right here, it is actually easier to do the substitution way. So I wrote that there on the right-hand side. It's easier to do it this way when you have a variable by itself. So like this is already y equals mx plus b. The y is all by itself. So what I'm going to do is I'm going to take this and I'm going to substitute this into y. Okay? Because think about what's happening. This is saying y is equal to this. Y is the same thing as 2x plus 4. So when I rewrite the second equation... instead of writing y, I'm going to write what y is equal to. Y is equal to 2x plus 4. So I know y is the same thing as 2x plus 4, so I'm rewriting this, the second equation. Instead of using y, I'm using 2x plus 4. And the reason I'm doing that is because now I have an equation with all x's in it. Okay, I don't have an equation with an x and a y. My goal here is to get an equation with just x's in it or just y's in it, and then I can solve it. So combine like terms here, and I get 3x plus 4 equals 7. And then subtract 4 from both sides, and I get 3x equals 3. Divide by 3, and x equals 1. Okay. So what we are doing here is kind of manipulating it or substituting it in to get one variable in an equation so we can solve it. Once you get one answer, it should be easy from there. All you're going to do is take that and plug it in. And you can plug it into any equation that you want to. You can plug it in the top one or the bottom one. I'm going to plug it into the top one because, let me turn that red. I'm going to plug it into the top one because, I don't know, just because. It seems easier. So I put a 1 in for my x, and I get 6. So these intersect at the point 1, 6. Oh, man. All right, doing the next one. Again, it's easier to use the substitution when you have a variable already solved for. So on this one, I already have x by itself. So it is easier to use the substitution on this one. So I know that x equals 4y minus 1. 4 minus y. So I'm going to take that and plug it into this x right here. So I'm rewriting the second equation. Instead of x, I'm putting 4, instead of x, I'm putting 4 minus y in there. And now I have an equation with just y's in it, so I can solve for y. So I distribute the 2, and I get 8 minus 2y plus y. And now negative 2y plus y would be negative 2 plus 1, right? So negative y equals 5. Continue solving this, and I get to get y by itself, I subtract 8 and divide by negative 1. And again, once you get one answer, take that and plug it in. I'll plug it into the top one again because it's already solved for x. And I get x equal 1, so these two intersect at the point 1, 3. All right, so the substitution method is easier when you already have the y that's solved for, like in y equals mx plus b form, or like right here we have the x by itself. The other way that we do it, which I think is the easier way a lot of the times, is called the elimination or the addition method. And what happens here is if we add these up, maybe we can make it to where a variable cancels out. So this one works easy for us. So this first topic's pretty easy. I have positive 1y and negative 1y. So if I were just to add up these equations, my y's would cancel out. I have x plus x is 2x, positive 1y, negative y cancel out, and then 5 plus 1 is 6. So they call this the addition or the elimination method because when I add them up, the y's get eliminated. And again, to know you did this right, like I have a simple equation with just x's in it. So I just divide by 2, and x equals 3. So this way is easier, a lot easier when you have, like, we don't have a variable all by itself. We got x plus y both on the left side of both of these. So this one is a lot easier to do on this. On the test, I really don't care which way you do it. You just got to match it up and all. So once again, once we get the one answer, we plug it in. I'll plug it into the top one. I don't really know why because there's not a negative in there. So subtract 3 from both sides, and y equals 2. So by adding these up, the y's cancel out, and then it makes it super easy to solve for the x's. Yeah, I think I'll do this one too. So this first topic, you don't have to do any manipulation or changing. We'll do that in a second. They should just already cancel up. If I add these up, I get 4x, 3 minus 3 cancel out, equals 12. It's not always the y's that cancel out. Maybe it's the x's that cancel out. But one of them's going to cancel out. So divide by 4, and x equals 3. And then once you get one answer, plug it in. I guess I'm going to plug it into the top one again just because there's no negatives. 6 plus 3y equals 12. Subtract 6 from both sides. Divide by 3. I got the same answer as the last problem, but it still works. So don't forget that is the point of intersection. This way is a lot easier, like I said, when you, especially when they just add up and they just cancel out like that, and they look real easy. You can plug it into either one. Okay. So what happens? I'm skipping to this one. Yeah. What happens if I have this problem right here? And if I go to just add these up, I get 7x plus 2y equals 12. Well, that doesn't help me at all because I still have an x and I still have a y. So what I want to do here, what I want to do here is manipulate it to where I can make them add up. So I see a positive and negative right here, and that's what I'm identifying. If I look at this, I know if I look at the positive 4y, how if I make it negative 4y, if I make that negative 2 be negative 4y, positive 4 and negative 4 would cancel out, right? So what I'm going to do is multiply this one by 2 so that I can get 2 times negative 2 be negative 4y, and then they'll cancel out. So I do 2 times everything in there. 2 times 4x, 2 times negative 2 is negative 4, 2 times 10 is 20. So this one I am manipulating it so that when I add them up, they're going to cancel out. So you may have to change 1 or 2 of the equations by multiplying it by something, and this will do a lot of this on Thursday. I just wanted to start it today to make it cancel out. So now 3 plus 8 is 11. 4 minus 4 cancels out. 2 plus 20 is 22. Then divide both sides by 11, and x is 2. So again, we are manipulating the equation so that when we add them up, the y's cancel out, and I'm left with just an easy x equation. One way to know you do this right, by the way, is Alex is pretty good about not giving you fractions. So like when you work the problem, you shouldn't get a fraction. And again, just like before, once I get 1, I'm going to plug it in. I'll plug it into the bottom one this time. So I plug a 2 in for my x. I get 6 plus 4y equals 2. Subtract 6 from both sides and divide by 4. And I get my intersection point of 2, negative 1.